In a previous video, we set up Koin within our Android application. In this video, we're going to take a look at the solid principles of object-oriented development and consider how we can leverage those with Koin when we have a class that we can extract an interface from. Then we can use that interface as a variable type, and the class that implements that interface as an object type, or any class that implements that interface as an object type. A reminder on solid. All of these are good ideas, although in Koin and in this video we're focused on the last three, even though they all apply. Single responsibility principle, a class should have one and only one reason to change. A class should only have one job. Open-close principle. Objects or entities should be open for extension but closed for modification. Now, looking more specifically at what we're covering here, Liskov Subsitution principle means that you can have a supertype and a subtype. Supertype could be a superclass, subtype could be a subclass, or supertype could be an interface, subtype could be a class that implements that interface. And in that case, the subtype should be substitutable for the supertype. So for that, we need to have an interface and a class in our case, which we will create. Interface segregation, a client should never be forced to implement an interface that it doesn't use, or clients shouldn't be forced to depend on methods that they do not use. So we're going to make a very specific interface for our plant service class that only has methods that are present in that plant service class. And then dependency inversion, and this is really the root of Koin, entities must depend on abstractions, like an interface, not concretions, like a concrete class. A high-level module must not depend on the low-level module, but should depend on abstractions. To put another way, take a look at our class diagram, and we see that the ViewModel points to the interface iPlant service, not to either one of the classes that implements that interface. So in this video, we need to make this interface because we've been developing this plant service without the interface. So now, in the interest of solid principles, we're going to make that interface. And our development environment makes this very easy on us. You see that we have plant service over here in the service package, and currently does not implement an interface. So we can right-click, refactor, and choose Extract Interface, and we'll say Plant Service KT. We'll name it iPlantService. And we're going to go ahead and take the suspend function fetch plants, and we're going to put it into that interface. Now take a look at line number 11 before, because we're going to look at it again after. So just take a mental screen capture of this class plant service on line 11. This is the interface that's created iPlantService, and now you can see that class plant service implements iPlantService. So it put the interface in the same file, which is fine. Or we could refactor it, move it to a different file if we want. For our use, this is just fine. You notice it has defined a function fetch plants, and that's really all an interface should do is define a function. It should not give behavior to that function. Now down here we have our plant service of type iPlantService, and it is providing a definition for that function fetch plants. So now we have taken the interface out of the concrete type itself, and we're able to make it so that our entities depend on abstractions, not concretions. Let's see how we can do this. Let's go to our main view model, and you see right now it is specifically tied to a plant service, which is a concretion. It's a concrete class. But since we now have an interface, we can update this and say iPlantService. And it's likely going to require that we import iPlantService, so we import iPlantService, and now we can check this box, entities must depend on abstractions, not concretions. Now we have a bit more work to do because we see here that we are actually creating an object of that plant service type and saving it into this variable. Now the nice thing is we're using a Kotlin trick here where we're doing this as a constructor parameter, but we're setting a default where the default object that's going to go into this variable is called iPlantService. What that means, which is quite nice, is that we can use that as a default, or if we want, we could use a different service if we want. And sure enough, we see here in the unit test we wrote in a previous video, we are passing in a mocked plant service instead of the actual plant service, and that helps us to unit test because we're mocking out our dependencies. Let's go one more step and register this class or this type in our Koin modules definition. So we see we already have one definition there, ViewModel, and that came about when we initially set up Koin to instantiate our ViewModel. For this one, we're going to not use a ViewModel because we're instantiating a service, not a ViewModel. And I'm going to say single, which is essentially a singleton. And then we'll say plant service and Alt-Enter to import. Now here's where things get neat. If we take a look at main ViewModel, we realize that it has a parameter of type iPlantService. Now it's an optional parameter because we're giving it a default here, and the default is plant service. And that works. But if we look at appModule, we have a neat option available to us. We can indeed call that constructor with no parameters, or we can call it by passing in a plant service object. If I simply type get, then Koin is going to take a look at all of its definitions for objects and see if it has one that matches the type that is expected here in this constructor call. And we know that what's expected there is something of type iPlantService, of which plant service qualifies based on Liskov Subsitution and to another degree interface segregation and dependency inversion. So Koin is able to set up that relationship and figure it out. Let's take one more step to be clear that plant service is indeed substitutable for the iPlantService type. And for that, within this single clause, I'm simply going to add iPlantService as a generic identifier and make sure that we import it. And now I'm going to run our application in the debugger so that we can ensure that it still works as it always has once we set up this Koin substitution and dependency injection. We'll give it just a moment to load. And we see as it's loading, we have our breakpoint hit within our main activity. As with before, I'm going to go ahead and run, and it's going to initialize the activity, and then it's going to kick off the live data, and if all works well, we should be able to verify in our variable that we are indeed retrieving live data, just as we did before. Aha! Now you see that by using Koin in its dependency graph and dependency injection, we are still getting data all the way from the DAO in retrofit all the way through the service layer, through the ViewModel, through live data, to our activity, because we see here this variable foo has 5,950 plants, and if we take a look in the variables tab in Android Studio, we can see that indeed these sure do look like plants. So in this video, we've taken a deeper dive look at Koin in Android and how it applies to the solid principles. If you're in a position where you're interviewing for a programming job, there's a good chance that solid principles will come up in your interview. And when I'm interviewing somebody, I always like when that person has a good, solid example that they can talk about when I ask a question. So think about this. Think about this as a study guide, and I sure hope that it helps you with your next interview, co-op, full-time job, or your current job as well, if that's where you are. As always, I hope you enjoyed this video, and I look forward to reading your comments. Thank you.